Welcome back to my YouTube channel. In this video, I want us to present a lesson which will help us to know the determination of sex in humans. As we can see, the title is written, the determination of sex in humans. Now, first of all, in human, there are about 23 pairs of chromosomes. 23 pairs of chromosomes. A pair is made up of 2 chromosomes. So now I'm saying that in humans, there are 23 pairs of chromosomes. Now, which simply means that, now I'm saying that a pair is made up of 2 chromosomes, or 2 things. So in this case, a pair is made up of 2. So which simply means that 23 times 2 altogether is giving us 46. So we have 46 chromosomes as the humans. So there are 46 chromosomes in humans. So 23 pairs. Now, out of these 23 pairs, 22 pairs controls what are called the body characteristics, and they are specifically called the autosome. So they are called the autosomes. So they control the body characteristics, the body physical features, except the sex linked or anything to do with the sex. So they control the body characteristics. So these 22 pairs are called the autosomes. This is AU autosome. Now the 23rd pair, meaning that the last pair, the one which makes it 23, it controls the sexy, characteristics, and therefore they are called the sexy chromosomes. So therefore, the sex determination or determination of sex is controlled by what are called the sexy chromosomes. Now we need to know these sexy chromosomes. We need to know the sex chromosomes in humans. Now in humans, there are 2 types of sex chromosomes. So in humans, there are 2 types of sex chromosomes. We have the X chromosomes and the Y chromosomes. So the types of sexy chromosomes. Okay, so it's not clear. The types of sex chromosomes. So types of sex chromosomes. So we are saying that in humans, there are 2 types of sex chromosomes. One, we have what is called the X chromosomes, the X chromosome, and the Y chromosome. So there are 2 types of sex chromosomes in humans. We have the X chromosome and the Y chromosomes. These are the chromosomes which determines the sex of a person. Now, these are not called the alleles, like in other characteristics which we call alleles. These are called the X chromosome, Y chromosome. It's not the X allele or Y alleles. It's not that. So we have 2 types of sex chromosomes, the X chromosomes and the Y chromosomes. Now, if an individual, comprises of the X chromosomes, X chromosomes, this individual will develop, the female characteristics, the female traits. So when an individual carries the XX chromosome, will develop the female traits. Now these female traits include the ovaries, having the ovaries, having the vagina, and the uterus. So having the vagina and the uterus. So when an individual has the XX chromosome, then this individual will develop the female traits or characteristics, which includes the ovaries, the vagina, and the uterus. Now, if the other individual develops the XY, if the individual develops the XY chromosome, which is the XY chromosome, this individual inherits what are called the male characteristics or male traits. The male traits, we're talking about having the penis, as well as the testes. So having the penis and the testes. So these are the sex chromosomes. Now, we need to represent this on the graph or on the genetic diagram. We need to represent how this individual can inherit the XX and how the individual can inherit the XY. So let us show the genetic, how an individual is determined to become a male or a female. How does someone becomes a male or a female using the genetic diagram? Now, just like any other genetic diagram, you have to start by writing the phenotype of the parents. So we have the phenotype. Okay, let me start from the other end here so that you can have enough space. So we have the phenotype of the parent. So in this case, remember we have male or female. So male, then in this case female. We are cross-breeding between the male and the female. Remember, we want to determine sex of a certain child. Then after phenotype, we have to write the genotype of the parents. Genotype. So the genotype of the parents, the genes which represent male. Now remember I said for male, it is XY. So which means we're going to have the XY here. Then the genotype of the female is XX, like that. Then from the genotype, you have to write gametes next. The gametes, the same symbols, but a bit further from each other so that we can show the actual crossing. So we have the XY, then we have the XX. Now here we have to put the times because we'll be multiplying these genes to the other side. Now each chromosome here should be multiplied with all the chromosomes on the other side. So it is possible that this X can combine with the X from the female. The X from the male can combine with the X from the female, and this will result in having the XX. Now it is also possible that the same X can still combine with another X the other side, which will also form the XX. So XX, you're going to get XX. So we are done with this chromosome. It has multiplied with all the chromosomes the other side. Same thing will happen with the Y. Y will also be combining with all the chromosomes on the other side, the female side. So Y is combining with these two here. So which simply means that Y will have to combine with this X. Always start with the X. X is bigger than Y in an actual sense. You see, so if you are to observe this in 3D, the actual, I'm talking about the actual chromosomes, the X is bigger than the Y. So you always start with X. So we have the X chromosome, then you are going to have the Y chromosome. Now the same Y can still multiply with the other X there. We have X and the Y chromosome. So what we have just shown here is the genotype of the F1 generation. So genotype of F1 generation. Then the phenotype of these offsprings. The phenotype of this offspring, which is the offspring of F1 generation, is we have two female. This, remember XX is female, so two female, then two males. Now if you are to study this diagram carefully, you must know who determines the sex of the child between the male and the female. You need to know who determines the sex of a child. They do ask that kind of question in an exam. Who determines the sex of the child? Is it the male or female? Now remember, this is a male, this is a female. Now in the female we have XX, male we have XY. According to the diagram, the person who determines the sex of the child is the male parent. This is because you can only inherit X from the mother side, but from the father side, you can either get X or Y. Now, when you get X chromosome from your father, that is male, then female here, then you get X from the mother, automatically you become the female. You can also get Y from the father, and you can only get X from the mother. So when you get X from the mother and Y from the father, you become the male child. So the person who determines the sex of the child is a male parent, because you can either get X, so if you get X from the father, from the male parent, you become a female. If you get Y from the father, you become a male. So this is how sex is determined in human. So, we've talked about the types of chromosomes, the X and the Y chromosomes. These are the ones that determine sex of the child. So this is how we can represent the diagram on how the determination of sex is done in human. Thank you so much for watching. Please consider to subscribe if it's your first time to watch my videos, and don't forget to join our online classes, especially for GCE, grade 12s, grade 9s, and even the Cambridge levels. The syllabus. Talk about the university students in chemistry and biology levels. We all offer such kind of subject. Bye-bye.